Hi guys, today we'll be solving some computer organization problems, computer organization architecture problems. So this is a PDF that I've got with some questions in it, which is very interesting. So let's look at how to continue solving this problem right now. So I'll be going through these questions one by one, and then we'll see how to answer them, right? So first question talks about mini computers from the 80s. It has 18 address signals, which is nothing but an 18-bit address bus. So every memory is addressed with 18 bits. So based on that, we need to answer the following questions. What is the address space of the computer? Since it is 18 bits, and every location can have either 0 or 1 bit according to a binary format as well. So number of address spaces will be 2 power 18. So calculating the same. Welcome to my session of computer architecture and organization. Today we are going to look at a question um, and we'll see how to solve it. So many computers in the 80s had 18 address signals and of course 18-bit address buses. Based on that, we have to answer the following questions. What was the address space of these computers? And so if there is 18 bits, right? 18 bits and every bit can hold 0 or 1. So based on the size based on the number of bits would be 2 power 18. So hence we can solve it like 2 power 18. You can further split this into 2 power 10 and into 2 power 8. Which is nothing but 2 power 10 is around 1 KB, right? 1 kilobyte. And into 2 power 8 is nothing but 256 kilobytes, 256 bytes. So therefore this is going to be 256 kilobytes, right? So this is the answer to this question. Next question. What may have been the largest possible memory of these computers in bytes if the memory location is 1 byte? If one memory location is 1 byte, which is nothing but 8 bits, one memory location is 8 bits, then what would have been the largest possible memory of these computers, right? So since the address, 18-bit addresses are there and the total memory size would come to 2 power 18, which is 256 kilobytes. Based on this, if we have to decide the largest possible memory of these computers, it would come to the same value, which is nothing but 256 kilobytes only, right? Because the maximum possible address space is what your memory can hold, then that is the largest possible memory as well, right? So therefore, the largest possible memory is also 256 kilobytes. Moving on. Question part C. How long should the program counter of these computers be? How long should the program counter? Since program counters holds every instruction, computer instruction, and there can be as many instructions as however large the memory is. So since the memory goes up to 256 kilobytes, you can also have the program counter of up to 256 kilobytes so that it can hold that many. That is based on the memory size. But program counter, each instruction will be stored in the memory address. So based on that, and each memory address is 1 byte or an 8-bit address. So hence, the program counter will be the number of bytes. In terms of the number of bytes, it's going to be 18-bit addresses, right? So it will be 18. We should be able to hold up to 18. Okay. What would be needed to change in these computers if we would like to increase the address space by 8 times? Okay. If we multiply the current address space and it has to become 8 times more, then technically, with 8 times more, then this is nothing but 256 into 2 power 3, right? So in terms of bits, bit and memory area, it's going to be 2 power 3. It has to increase by 8 times. So you have to add 3 more bits in the address bus, 3 more bits the address bus to be able to increase the memory to thrice the size, to thrice the current size, right? So this is how we answer these questions. Hope it was useful, and I will see you soon in our next session.